Okay, let's look at a few more examples here of using trig ratios to find lengths. Okay, so we're going to do 4 in a row here, really pretty quick. Obviously, again, we're going to remember our main theme of so, ka, toa. Okay, so again, that's going to help us with these trig ratios. Okay, so again, we're going to find the length and round it to the nearest hundredth. So again, we're looking at df. Okay, so df is actually what we are looking for. All right, now, the given angle that we actually have here is angle D, right? So we know this, okay, we know that that's 51 degrees. It looks like we know the opposite side, and the side that we want to know, df, is the hypotenuse, okay? So again, opposite and hypotenuse, it looks like sine is the one that we're actually going to want to use. Okay, so we'll say that the sine of 51 degrees, again, is going to be equal to opposite over hypotenuse. Okay, we'll go ahead and fill in the values that we actually know here. Right? We know the opposite side is 17 meters. So I'll say that the sine of 51, sorry, I'm dyslexic today. The sine of 51 degrees is going to be equal to 17 meters over the hypotenuse, which we'll just call df. Okay, now we're trying to isolate df in any way we can. Again, we can use the cross products property, or I just like to multiply both sides by df. Okay, I know that df and df will cross cancel there, and I'll be left off with now df multiplied by the sine of 51 degrees is going to be equal to 17. Okay, and I'll have to divide both sides by the sine of 51 degrees. Actually, better yet, I'm going to do this in black so we kind of can see the different operations there. Okay, so we'll divide by the sine of 51 degrees. Okay, and that's pretty much going to be our answer here. Sine of 51 over sine of 51 will divide to 1 and cancel there. So basically now we have that df is going to be equal to 17 divided by the sine of 51 degrees. Okay, and this is where we go to our calculator and just punch in 17 divided by 51, and press the sign button, and then the equals sign. It looks like we get about 21.87. So df equals 21.87 meters. Okay, and ask yourself again, does this actually make sense that the hypotenuse is longer than the leg? And absolutely it does. Okay, so let's go ahead and check out maybe a couple more examples here. Okay, so we'll go ahead, look at it. Here's another one. Okay, this one says again, find the length and round to the nearest hundredth. Okay, it's the same kind of theme here. So let's check out, what we actually know. Remember, we're looking for ST. Okay, we know that T is 42 degrees, so this is kind of angle T is what we're looking at. It's 42 degrees. To me here, it looks like we know the right angle is over there, so this is the hypotenuse, right? It's connecting the legs. So we know the hypotenuse, and we want to know ST, which is adjacent. And so again, I'll look at so, ka, toa. Okay, and I can see that if I have the opposite, if I have the hypotenuse and the adjacent side, it looks like we're going to be using cosine. Okay, so I'm going to say that the cosine of 42 degrees is equal to adjacent over hypotenuse. Okay, and again, I'm going to rewrite the cosine of 42 degrees is going to be equal to ST over our hypotenuse is 9.5 inches. And so to isolate ST, I will multiply both sides by 9.5. 9.5 divided by 9.5 will just kind of cross cancel there. And it looks like I'll get ST is going to be equal to 9.5 times the cosine of 42. So I'm going to put 42 cosine first. And then that results about 0.74, and I'll multiply that by 9.5. Looks like my final answer here is 7.06 if I round it. So 7.06 inches, okay? And again, that's the leg. It's just a little bit less than the hypotenuse. And again, to me, that kind of makes sense, okay? Let's take a look at one last example here, see if it actually helps us out, okay? This time we're looking at BC. Okay, so we want to know BC, okay? it looks like we know that angle B is 18 degrees, so that's helpful. Okay, we're looking at this particular angle, and that's, you know, we'll use either sine, cosine, or tangent of B. We know the opposite leg. Okay, this leg is not adjacent, it's not connected to angle B, and we want to know the adjacent side. Okay, the adjacent leg is connected to that vertex of B. Okay, so it looks like if we look again at SOHCAHTOA, if we have the opposite and the adjacent, it looks like tangent is what we're going to use. So we'll say that the tangent of 18 degrees equals the opposite over the adjacent. Okay, the tangent of 18 degrees is going to be equal to 12 feet over our adjacent side, which we'll just call BC. Okay, to start to try to isolate BC, I'll try to move it to the numerator by multiplying both sides by BC, which BC will then cross cancel, and I'll get BC times the tangent of 18 degrees equals 12. Still don't have BC by itself, so I'm going to divide by the tangent of 18 degrees on both sides. Okay, tangent over tangent will kind of cancel there, and I'll have that BC is going to be equal to 12 divided by the tangent of 18 degrees. And now I can go ahead and move my calculator. Okay, so I'll take 12, I'll press 12, the divide button, I'll put 18 in tangent, and I will press enter, and it looks like about 36.9 feet is what we'll get. So BC equals 36.9 feet. Okay, obviously that longer, it looks like, you know, much longer than the short leg, and that seems to be about right. Okay, so I hope these extra videos were helpful. We'll look at one application problem here next.